This will be a short review of nomenclature of ionic compounds. Now the tendency of atoms to combine is in order to achieve noble gas electron configuration. Now the charges you should also know by looking at periodic table. You should realize if you are in group 1, group 2, or group 3, your metals, you like to lose electrons and form cations. If you are in group 1, you always form 1 plus charge by losing 1 electron. Group 2, you lose 2 electrons, 2 plus, and these are some examples of that. Lithium, group 1, sodium, group 1, magnesium, calcium, group 2. And group 3 or 13, aluminum is the only metal we are concerned with. It loses 3 electrons. Now if you look at group 15, then you have nitrogens and phosphorus. They like to gain 3 electrons, therefore -3 is their charge. Group 16 has 6 valence electrons, needs 2 electrons to make it to the closest noble gas, so 2 minus. And finally halogens, they like to gain 1 electron, group 17. Now let's just look at calcium nitrate. Calcium nitrate is formed by addition of calcium and nitrogen. If you look at calcium, it has 20 electrons, and if we lay out electron configuration, in terms of noble gas, it's argon 4s2. On the other hand, nitrogen has only 9 electrons, and it is 1s2, 2s2, 2p5. And that's why nitrogen needs 2 more electrons to make it to the closest noble gas, neon. So what happens is calcium is going to lose 2 electrons, and this process is also known as oxidation. We're not going to worry about it so much, but by losing 2 electrons, it forms calcium 2 plus. Now this has electron configuration of argon. On the other hand, if you look at nitrogen, it's going to gain 2 electrons, it's going to gain 3 electrons, and when it does that, it forms nitride ion 3 minus, and right now this has noble gas of neon. So they are both content. Let's put them next to each other, and if you remember from year before, so calcium is 2 plus, nitrogen is 3 minus. You swap the charges, crisscross or switch, however you remember it, 2 and 3. Why do we do that? In order for them to, when they are multiplied, they have the same charges. So 2 times -3 is -6, and 3 times 2 plus is +6, and that's neutral. Then you just report it as Ca subscript 3 and subscript 2. That's your final answer, and that's calcium nitrate. Their transition metals you also have to respect, and they have Roman numerals. Transition metal has a specific definition. It should at least have one oxidation state with partially filled d orbital. So there are 2 elements in this period 4 that are not transition metals, scandium and zinc. These are only known as d block elements. So these are d block elements and not a transition metal. So you have to be careful with that. But the rest, if you look at titanium, it has the following possible oxidation states: vanadium and chromium, manganese, iron, cobalt, nickel, although we show +1, but it has another possibility of oxidation state, copper with 2 oxidation state. So these are transition metals. And when we do their nomenclature, we have to be careful with their oxidation state, because we have to spell it out. So some examples: chromium 3 chloride. The 3 belongs to chromium, so it's trying to say I'm Cr3 plus, and chloride is simple ion, group 17, so it's Cl1 minus. We swap or switch the charges, therefore it's Cl3. Manganese 7 oxide, then again 7 belongs to manganese, it's not magnesium, and we are talking about this, so it's Mn 7 plus. Oxygen group 16, 2 minus, swap the charges or switch them, so Mn2O7. Copper 1 nitrate, so Cu is 1 plus. Nitrogen group 15, so 3 minus. Then swap the charges, so you have Cu 3 times N once. So transition metal is also part of your nomenclature for ionic. They are metals with variable oxidation numbers. Finally, you should also remember polyatomic ions. And these are the most that you need to know. There are more than this, but for time being, ammonium is the only one that is a cation. It's a positively polyatomic ion. The rest are anions. So these are anions, negative charged ions. Hydroxide, you should know, OH1 minus. Cyanide is CN1 minus. Nitrate, acetate. Sometimes acetate is shown as C2H3O21 minus. I still prefer CH3COO minus to remember it. Hydrogen carbonate is HCO31 minus. Carbonate is 2 minus. Sulfate is 2 minus. Phosphate has the most of negative and it's 3 minus. Now let's just put them together. So one example of each. If you are challenged with sodium phosphide, sodium is group 1, simple ion, 1 plus. Phosphide means it's just a monatomic and it's a nonmetal, group 15, so it's 3 minus. Swap the charges, so Na 3 times, phosphorus 1 time. Copper 2 phosphate. Copper 2 indicating I'm a transition metal, Cu2 plus. Phosphate 8 indicates that I'm not monatomic, I'm polyatomic. Somehow you have to memorize PO4 3 minus. Swap the charges, so Cu 3 times. If you have more than one polyatomic, you have to put it in parentheses twice. Ammonium sulfate. Ammonium NH4, 1 positive. You have to memorize it. Sulfate SO4, 2 minus. Swap the charges, so you need 2 ammoniums in parentheses, 1 sulfate, and that's your compound. Now this time you are given a formula, you have to come up with the name. This is chromium. First thing to do is remember chromium is transition metal. Open a parenthesis, last name is nitride. Now you have to worry about the Roman numeral. One way to solve for this is nitrogen is group 15, so it's 3 minus. When you multiply this 2 should equal to this side, and there is a subscript of 1. Even if you don't see, multiply by a question mark. So 3 times 2 is 6. 1 times what should equal 6, and that question mark is 6. So I need VI Roman numeral 6. The next one is ammonium fluoride. And the last one is sodium hydrogen carbonate or sodium bicarbonate. Sodium hydrogen carbonate. So this was a brief review of nomenclature of ionic compounds. You should have had experience with this.